So let's talk about common shaders and their uses. So first of all, the word shader means slightly different things to different people and in different pieces of software. So when I hear the word shader, I generally think of what's called a surface shader, which is a set of equations used to determine the appearance of a surface and how it responds to light. So in Max, you have something called a material, and a material is a shader which is then combined with various maps or patterns, and those change the various attributes of your shader. So some common shaders in the CG world, there's the Lambert shader, which is just a simple diffuse shader. There's Phong, which is a type of highlight. There's Blinn, which is a different kind of highlight. The Ornaire shader, which is diffuse for rough surfaces. The Ward anisotropic shader, which does anisotropic highlights. And then there's also the Cook-Torrance shader, which is commonly used for metal. There used to be a Cook-Torrance shader for Max back, I think, in like version 4 or 5, but I don't believe it ever got recompiled, so I don't think one exists anymore. So in 3D Studio, each renderer has its own set of specialty materials that come along with it. So for example, the scanline renderer, which is built in the original renderer in Max, has a standard material and also the ray trace material. And then Brazil 2 lets you use the Brazil 2 advanced material, as well as it has a few other specialty Brazil materials, and you can also use the standard material or ray trace material inside of Brazil. And then in Mental Ray, the main material you'll probably be using is the architecture and design material, although once again there's also a bunch of specialty Mental Ray materials, extra ones, and also you can use the standard material with Mental Ray if you want. So here's Max's material editor, and we'll start off with talking about the scanline renderer and its main material, the standard material. So you can see an example of it up here, and it's broken into two basic parts. You have the shader area, which is up here, and then you have the maps area, which is down here. And under the shader, there's a bunch of different shaders that you can choose. Now if you're using a Blinn, and if you have no highlight at all, what this shader actually is this is the same as a Lambert shader, which is just a very simple diffuse shader. The moment you take the specular level or the glossiness and change these values, you're now bringing in a highlight, and this highlight is called a Blinn highlight. So a highlight is just a simplification of something called a specular reflection. So there are two kinds of reflections a surface has. One is called a diffuse reflection, and one is called a specular reflection. And when people talk about a diffuse reflection, they tend to just use the word diffuse by itself. And when people talk about a specular reflection, they tend to use just the word reflection by itself. So this is a photograph of a water bottle, and we can see something that looks like a highlight here. But as we get closer, we see that it's actually a reflection. And it's a reflection of the lamp that's up above the water bottle. So back in the early days of Max, stuff like ray tracing was around, but ray tracing was a very slow process. It took a while to render a scene, and so what they did was they took the process of a specular reflection and broke it up into two pieces. You have a specular highlight, which is up here, and then you have the reflection, which is down here. And so what a highlight is if you create any standard light, like an omni light, for example, the highlight is actually a fake reflection of that light source. And so this allowed you to get something that looked like a highlight or a reflection without actually doing the costly reflection down here. Now these days, since computers are a lot faster and ray tracers are far more common and they're faster, a lot of people don't even use highlights anymore. They only use pure reflections down here. But highlights are still certainly good things to know about, and certainly good to use in some situations. So here we have a Blinn, and if I switch to Phong, this is another kind of specular highlight, and you can see here the difference is down here at the glancing angle. So you get this big long highlight with Phong, and if you go to Blinn, you can see the highlight gets a lot rounder. So feel free to use either of these two, depending on what sort of look you're going for. Now, another kind of shader is the Ornaire Blinn, and let's just turn off the Blinn portion for the moment. So this is just a regular Ornaire shader, and it has something called roughness. And if you turn this down to 0, you can see that the Ornaire shader looks pretty much identical to the Lambert diffuse shader over here. But as you turn up roughness, it pulls more and more of the dark ambient into the diffuse color. And this simulates rough surfaces. So stuff like rubber, stuff like rock. I also use Ornair a lot for rust materials. So another shader is called the anisotropic shader. Sometimes it's known as the Ward anisotropic shader after Mr. Ward, who invented it. So this is similar to a Blinn or a Phong highlight, except the highlight you can see is stretched in a particular direction, and that's controlled by these controls down here. Now, you may have seen something like this before, and this is a render of a teapot sitting on a surface that has real anisotropic reflections going on. And you can see how the reflection is being stretched in a particular direction. And this is what you might get if you put a real teapot on, say, a piece of brushed metal. So, same sort of thing here. You see the cone, and the reflection of the cone should be the same height as the cone, but over here you can see that the height is stretched in a particular direction. And same thing here. You get these kind of anisotropic highlights on things like CDs or, in this case, on the bottom of a pot. So what this is your material has a bunch of tiny, tiny, tiny grooves, and the grooves all have to be going in one particular direction, like they are here. And what this will do is this will take the reflection, and it'll stretch the reflection in the opposite direction to where the grooves are going. So if the grooves are all going horizontally, like here, your reflection is going to be smeared perpendicular, so it's going to be smeared vertically. So here's how that works. So this is a doorstop, and you can see on the doorstop you have all of these little reflections here, and the reflections are of the light source that is up top. So let's pretend for a second that we just had one of these little guys. So we have one little ring, and we have a reflection of a light source which is up here on the ring. Then if you add a bunch of rings together, you end up getting a whole bunch of little highlights, and each highlight is at a slightly different angle than the previous one. So when we pull back the camera, it appears as though the reflection is stretched. But in actual fact, it's not stretched. It's just that we're seeing a whole lot of little small reflections that all combined together appear as though it's stretched. To learn more about anisotropic highlights and reflections, please visit my website. I have a tremendous amount of information there on these kinds of reflections, and you can totally geek out and learn way more about these kind of reflections than you ever wanted to know. So the main thing to notice in the standard material is you have the same specular level and glossiness controls you have in a Blinn, but then you also have the anisotropy, and if you change this, the highlight will get thinner or thicker. And then the direction is controlled by the orientation, which is down here. Now, down here, of course, is still the reflection, and one thing to note is in the standard material, you can have an anisotropic highlight, but you can't have an anisotropic reflection. So any actual reflections you do will remain unstretched, but the highlight can be stretched using all these controls up here. So now let's discuss the metal shader. And the metal shader seems like the perfect shader to use for metallic surfaces, except for the fact that this metal shader is a vast oversimplification of a much more complex shader called a Cook-Torrance shader. And this is so simplified, in fact, that it really takes away a lot of flexibility that you need for production. So for an example, say you have this material here, and the director says, I love that highlight, that looks really good, but I don't like the black. Can you just bring the diffuse up a bit? So you go here and you say, okay, I'll bring up the diffuse, and that doesn't really seem to do very much. And then you go down here and you start playing with the highlight, and eventually you're like, okay, well, I can get some more diffuse color in here, but in order to get the diffuse color, I give up that nice strong highlight that I had before. So that kind of follows the real laws of materials like this. So if you have a very reflective surface, it tends to not have much diffuse. It tends to be mostly specular reflection. And that's kind of what it's doing here, but it just isn't very flexible. So if you need to just tweak the values a little tiny bit, you're going to have a lot of trouble getting the results you want. And so that's why I don't use the metal shader anymore, and instead I use a Blinn to do the same thing. So you can have your really strong highlight here, and then if the director says, can you bring just a little diffuse color into here, you can go into your diffuse and you can just add it. So as long as you keep this diffuse reasonably low in value, you'll still get something that looks reasonably realistic, but at the same time you have the flexibility that you really need for production work. So now a quick bit about the ray trace material in the scanline renderer. So back in the, I believe it was Max 2 days, two guys at Blur named Steve and Scott wrote the RayFX ray trace engine. And they licensed it to Autodesk, and it was included inside of 3D Studio. And what this let the scanline renderer do was do selective ray tracing. And now this ray trace material is the main way to access the RayFX engine. And I don't use it much anymore, and it's mostly because I'm now a Brazil user, and Brazil was written by a company called Splutterfish, which was started by the same two guys who wrote the RayFX engine. So really, in some ways, Brazil is sort of like the next generation version of the RayFX engine inside of the scanline renderer. So main reason I want to show you this is because it's still useful if you want to use the scanline renderer, not only as a way to do reflections and ray trace reflections, but also it's just a much more flexible material than standard. And back before Brazil, I would use this material for almost all my materials instead of using the standard material. So the main thing I want to point out is that in the standard material you had the specular reflections are broken into two parts. You had your highlights here, and then you had your reflection down here. And in the ray trace material, this is now broken into three parts. So you have, again, your highlight is up here. And then down in here, you have two slots, one called the environment slot and one called the reflect slot. And the reflect is what tells it how reflective the material is, and the environment is what you would like it to reflect. And in the standard material, both of those are sort of combined into one map here. So it's actually kind of nice to have these split up into two separate maps. So the main way to do reflections is you first of all need something in your background to reflect, and then you have your reflect slot here. And as you increase its value, it becomes more reflective, and as you decrease it, it becomes less reflective. And then the main way you'd use this, you go to this reflect slot, and you place a fall off in there, and then set this to Fresnel, and then set this IOR. And again, as the IOR goes up, it becomes more reflective, and as it becomes smaller, it becomes less reflective. And something else you'll notice here is that it's more reflective at the edges than it is in the middle. And that's what the Fresnel reflection is. And this mimics what real reflections do. So here's a photograph of myself. I'm taking a photo of me in a piece of glass, and you can barely see the reflections here. But then as I turn and I look at the window from an angle, you can see that this is now really quite reflective. And that's the Fresnel reflection. So at the edges, it's going to be much more reflective, and at the middle, it's going to be far less reflective. So if you know the basic IOR of many materials, you can then use the fall-off map in your reflect slot to get the proper reflection for any material that you might want. So now let's talk about the Brazil to advanced material. Now you can use the standard material with Brazil and it will work fine. But in general, if you want a far more powerful material with a lot more options, the Brazil to advanced material is the way to go. So I'm going to discuss a few of the features that are different, and the first thing I want to talk about is the idea of energy conservation. So here's the law of energy conservation in a nutshell. Say you have a light source and it's shooting out a light energy of 1. The most that the object can reflect back into the viewer's eye is equal to the energy that hit it in the first place, so therefore a value of 1. Now, light that comes off a surface can come off as either a diffuse reflection or a specular reflection. So this creates a pretty simple formula, which is that the diffuse reflection plus the specular reflection has to equal 1, or whatever value of energy hit the object in the first place. So if you have a big diffuse, like say a value of 0.75 for your diffuse, then that means that your specular has to be 0.25. Or if you have a small diffuse, like 0.3, then the specular has to be 0.7 to keep this equation the same. So the idea is that the more diffuse an object is, the less specular it is, or the less diffuse an object is, the more specular it is in order to conserve energy. So inside the standard material, the laws of energy conservation are left up to the user to do. So say if you have a diffuse and you make it a really strong, bright value, and then you have something in the reflection slot down here, you'll notice how this thing is glowing. And the reason it's glowing is because all it's doing is it's just adding the diffuse to your specular reflection and giving you a result. And so this is glowing because it has a value that's bigger than 1. So if you want this to follow the laws of energy conservation, you have to do it manually. So if you have a strong reflection, you have to manually go and reduce the diffuse to something more normal, and then you'll get results that are more realistic. The Brazil Advanced material does this for you. So if you have, let's say you have a diffuse here of a gray color, and you start increasing the reflectivity, you'll notice the gray color of the diffuse disappears and it becomes purely reflective, so a strong specular reflection. And then if you bring the reflection down again, you'll see that the gray diffuse color reappears in the surface. So this automatically handles the energy conservation for you. Now you may remember the metal shader that I showed you a little while ago, and I talked about how it does something similar to this but doesn't give you a lot of options. And so that's what's nice about this. Yes, this does do some stuff automatically for you, but if you don't want it to do that, you can change it. One way is by changing the reflection control from blend to additive, in which case this works exactly like this does. But the other thing you can do is, say you have it being pretty reflective, and then the director says, I want a little more diffuse going on in there without giving up your reflection, you can actually go to the KD value and increase that. And then that will bring more diffuse to the surface. So this is a way that you can go in and you can manually tweak the values that you're given, but at least the initial values that it gives are already looking pretty realistic. And then the tweaking you do on top is just to sweeten it. Another thing the Brazil 2 Advanced material can do is it can tint reflections. So if you have a material like a plastic, the reflections are the color of whatever the original object is. But if you have a metal material, like say something like gold, the reflections are actually tinted the diffuse color of the material. So say for example you have as I said, gold, so we'll make sort of a kind of goldy type color. And if you left it like this, it really doesn't look like gold because the reflections need to be tinted something similar to what the diffuse is. And you can do that by changing this tint value. So I can copy that value there, and you'll notice how the reflections are now tinted the same color as the diffuse. And that's a really quick and easy way to make various metals like gold or bronze or something like that. Of course, you also want to tint the highlight they have on the surface to once again make it look more like real gold. Now under the reflection parameters, there's a lot of different things in here, but the one area I want to show you is the glossy reflection control. So if you turn this on, what this does is it blurs the reflections you have in your surface. So when I talked about the anisotropic shader earlier, I talked about what happens when you have a whole lot of grooves that are all stretched in a particular direction and what that does to the reflection. So if you have a bunch of grooves but they're all sort of in random directions, what you'll get is a blur that happens in all directions simultaneously. So it's not all in one direction, it's all over the place. And that's what the glossy reflections are for. So bringing this value down makes it more blurry, and bringing it up makes it less blurry. So this is really useful to make certain kinds of metals. Another thing to note is if you go under the highlight shader and you choose blend, you'll see that the anisotropic controls are inside of the blend shader. So instead of having a separate anisotropic shader, it is built into the blend highlight. So if you have your highlight here, you can change the values to make it thinner, and you can change the angle, much like the regular standard material does. It's just all built into one shader now. Also note, Brazil does not actually do anisotropic reflections. It does anisotropic highlights, but the actual reflections themselves cannot be stretched. And then the last thing I want to show you is under the base shader area here, this is the Brazil default shader, and there's a bunch of other shaders down here like Lambert, for example, or Nair. And you can play around with these. The only one I was going to show you really briefly is the car paint shader, which for some hard surface models, I mean cars are definitely one of the most common hard surface models you're likely to do, this can be really cool because it gives you controls for multiple highlights and little flakes and all kinds of other details that happen inside of car paint. So if you're going to do a lot of cars, this is definitely the shader you want to be using. So now let's discuss mental ray. And one of the main materials you'll probably end up using is the architecture and design material. And even if you don't use mental ray, it's cool to take a look at this because you really start to realize just how similar all of these renderers are, and how really it's the same material again and again. It's just ordered in a slightly different way, and might have a slightly different name for a bunch of the same parameters. So once you've created one of these guys, the first thing usually you'll do is you'll select a template. For example, let's select rough concrete. What this does is this sets a whole lot of the stuff down here for you automatically based on what sort of material you want. But you can always go in here afterwards and change things to be more like what you actually want. So if we start up here, we see we have stuff like the color and roughness, and this roughness is exactly the same as the roughness in the Ornair shader. So a roughness of 0 is more the Lambert, and as you increase this, it gets more and more rough in the surface. So then in the reflection controls, one thing that's a bit different about mental ray from either the standard material or Brazil is that the reflection control controls both the highlight and the reflection. So the whole thing is all together in one area. And you'll notice right now you don't see a reflection in the background. You just see a reflection of the highlight. And the reason for that is because this highlight thing is on. So if you turn this off, you can start seeing that you have a reflection going on in the sphere here of this checkered background. And then the glossiness control controls the strength of the glossiness. So actually here, just for 1 second, let me just turn this bump off. So, and we'll increase the glossiness samples. So as glossiness is at 0, this is a very rough surface, and so you don't see any highlight at all. And as you increase the glossiness, you start seeing your reflection, and you also see a reflection of your point light source. And then also in here you have the metal material checkbox. And what this lets you do is this lets you tint the color of your reflections, whatever the color of the material is. So this is like in Brazil where you had the reflection tinting. This is what you use if you want to do stuff like gold or whatnot. So if we continue down, we can see that there is anisotropic controls, which are pretty much identical to the ones in the standard material or in the Brazil material. The only difference is that mental ray, as well as doing anisotropic highlights, will also do anisotropic reflections. And you control it with using the same controls for both the highlights and the reflections. Then down in here, in the BRDF section, you have a curve which you can control, which just lets you fine-tune the reflectivity. And then finally under here in special purpose maps, and I don't know why it's called special purpose maps, because these seems like maps I would use all the time, but this is the area that you have your bump and the area that you have your displacement if you're doing material displacement. And this is also where the environment slot is, which does the same thing as the environment slot in the ray trace material and in the Brazil advanced material.